Alright, we're going to go ahead and get going. I know some of you are still writing, so just kind of listen while you write. I would say most of what we do today is pretty simple. So chapter 6 is all about polygons and properties and different types of polygons and things like that. So a polygon is a shape with sides, basically. So the part poly means many, and then the gon is the figure part. Now there are specific types of polygons. We already know that there's triangles, which has 3 sides. We've done a lot with triangles. Triangles are a polygon. We of course have squares and rectangles, but a 4-sided polygon is going to be called a quadrilateral because we have squares, rectangles. We also have what we're going to learn later: kites and rhombuses and other things, parallelograms, trapezoids, all sorts of 4 sides. So a 4-sided figure generally is called a quadrilateral. We have 5-sided polygons, which are pentagons, 6 sides, hex, 7, septagon, 8, octagon, 9, nonagon, and then 10 is decagon. Anything above 10, we're just going to call it an 11agon, 12agon, 13agon, and so on. Okay? There are specific names for some of them above that, but we're just going to, after 10, we'll just use 11, 12, and on from there. Okay, so we're going to learn 3 theorems today. 2 of them are almost exactly the same thing, which is why the second theorem is called a corollary. Remember, a corollary is proved super easily using the previous theorem. So the first theorem we're going to talk about is the polygon angle sum theorem. So we're talking about any polygon, so any figure with sides. If you want to find the sum of the measures of the interior angles, so we've got a triangle. We already know what the sum of the interior angles of a triangle are. What is the sum of all the angles of a triangle? 180, right? But whenever then you move to a square, what is the sum of the angle measures of a square or a rectangle? 360. It's not the same thing. Okay? And you can keep getting bigger. That the sum of the interior angle measures changes depending on how many sides and angles the polygon has. So we have a formula that we can use to find out the sum of the interior angle measures. It's going to be n minus 2 times 80, where n is the number of sides and angles that the figure has, which makes sense because a triangle has 3 sides, right? So if you take 3 minus 2, you get 1, and 1 times 180? 180. Okay. It also works for a square, right? A square has 4 sides. 4 minus 2 is 2. 2 times 180? 360. So if I wanted to use this formula to find the sum of the angle measures, the interior angle measures of a heptagon, how many sides and angles does a heptagon have? Heptagon. 7. We'll go with 7. I'm going to set that wrong over there. 7 sides, okay? So we are going to take 7 minus 2 times 180. Make sure you follow order of operations. You're going to have to take the number of sides minus 2 first. 7 minus 2 is 5. 5 times 180 is going to give you 900. If you added all the angle measures of any 7-sided figure, any heptagon, you would get 900. Now, what we're going to be really interested in is certain types of polygons. So we have 3 different types of polygons we're going to talk about. You have an equilateral polygon, which like an equilateral triangle. An equilateral triangle has 3 sets of congruent sides. An equilateral polygon just has all sides congruent. An equiangular polygon, all angles are congruent. Now with triangles, if it was equilateral, it was equiangular. We had a theorem that told us that. But triangles are the only polygons that work out that way. For all other polygons, just because it's equilateral doesn't necessarily mean it's equiangular. Now, if it happens to be equilateral and equiangular, meaning all the sides and all the angles are congruent, then it is what we call a regular polygon. These are going to be the polygons we're pretty interested in today. There's going to be a lot of cool things about regular polygons when all the sides and all the angles are congruent. So, for example, The corollary to the theorem we just talked about, remember the theorem we just talked about said, here's how you're going to find the sum of the interior angle measure. So if you add all of the angles in the shape, here's what you get. Here's how you can find that. Now, if it's a regular polygon, I know that all the angle measures are the same because they're congruent. So the corollary to Theorem 6.1 just says, okay, well, if I can find the sum of all the angle measures, if it's a regular polygon, I can just divide and find the measure of one of the angles. And that's exactly what this is doing. Notice this formula looks pretty much the same, right? N minus 2 times 180. But then what you're going to do is you're going to divide by n. Because n is going to be the number of angles you have. This is the total angle measures. Divide by how many angles there are. That will tell you what is the measure of one of the angles. So if I wanted to find the measure of an interior angle of a regular nonagon, how many angles and sides does a nonagon have? 9. I first need to find the total angle measures. So we would take 9 minus 2 times 180. 9 minus 2 is 7 times 180, which would give you 1,260. Now, that's the sum of all of the angles, all 9 angles in this figure. So if I want to find the angle measure of just one of them, that's why we divide by n. That's why we divide by 9. We would take 1,260 and divide by 9, and we get 140 degrees. If it's a regular nonagon, every single angle is going to measure 140. Now, the last theorem is going to talk about, instead of the interior angles, it's going to talk about the exterior angles. We did talk a little bit about exterior angles when we learned about triangles. Now, an exterior angle is going to be when you extend one of the sides. So, if I extend this side right here, that angle right there is the exterior angle. Okay? Now, here's the thing. There's 6 different exterior angles. I have this exterior angle, and this exterior angle. But I could go around the triangle the other way, right? And I can talk about this exterior angle, and this exterior angle, and then this exterior angle. See that? Okay? So this theorem, what's important here is you have to make sure you're going around the polygon in the same direction. Okay, so if you were to extend this side and then this side and this side, see how they're all going the same direction? Okay, this is a pentagon, right? 5 sides. Okay, it has 5 angles, so it turns out it has 5 exterior angles. If you add all 5 of these angles together, it is going to equal 360. And it doesn't matter that it's a pentagon. The same thing is going to happen for a square. If you look at the exterior angles of a square and add all 4 of those exterior angles, you're going to get 360. If you did that with a triangle, it would be the same thing. If you did it with a 10-sided figure, it would be the same thing. For any polygon, okay, the exterior angles, the sum of the exterior angles is going to be 360. Okay, so if I'm looking at this picture here, okay, and I should have included a word here. I want to find the measure of angle 1 in the, I'm going to have to call it a regular. I would have to know that it's a regular pentagon, knowing that all those angles are the same, which, kind of taking that a step further, if all the interior angles are the same, what could you then conclude about the exterior angles? They're also congruent, right? So I already said that I know that if I add the measure of angle 1 plus 2 plus 3 plus 4 plus 5, I'd get 360. So if I wanted to find the measure of just angle 1, how would I do that? Divided by 5, right? All of those added together give me 360. There's 5 of them. I know they're all the same because it's a regular pentagon. So if I divide by 5, I'd end up with 72. The measure of angle 1 would be 72 degrees. Okay, let's make sure we all have our notebooks set up correctly. Remember, the first full 2 pages is going to be page 1 and page 2. Page 1 is going to be your table of contents. Your vocab that you guys did yesterday is going to be glued on page 2. Today's section is going to be glued on to page 3. This is section 6.1, and it is the polygon angle sum theorems. All right, so a lot of what we do today is using those formulas for how to find the sum of the interior angles, and then using that same one, if it's a regular polygon, you can then find the angle, or the measure of just one of the angles. So, for the first ones, I'm going to find the sum of the interior angle measures of each polygon. So for number 1, let's say I have an 11 gon. Now remember, sometimes there's special names. Some places use special names above 10, but for this one, if it's above 10, we're just going to say an 11 gon, which means how many sides and angles does it have? 11! Good guess. Okay, so if it has 11 sides, to find the sum of the interior angles, this is where you're going to take the number of sides, which is 11, subtract 2, and then multiply by 180. Make sure you do the subtracting first in parentheses, right? PEMDAS says to do parentheses first, so you would take 9 times 180, which would give you 1,620 degrees. And if I had a 14 gon, not even 40, that would be a massive one, a 14 gon, okay, which means it has how many sides and angles? 14. So to find the sum of the interior angles, we would take 14 minus 2 times 180, which would be 12 times 180, which would give you 2,160 degrees. You know, the next thing is we're going to take it a step further and then say, okay, let's say these were regular polygons. Just remember, for regular polygons, all of their sides are congruent and all of their angles are congruent. So we're going to do basically the same thing, but we want to find the measure of one interior angle. So you're going to find the total and then divide by how many angles you have. So if I wanted to find the measure of one interior angle of a pentagon. Okay, well, to start off, how many sides and angles does a pentagon have? 5. So I first need to find the sum of all of the angle measures. So we're going to use that formula. We're going to take 5 minus 2 times 180, which would be 3 times 180, which would give me 540. Now remember, that's all of the angles. I don't want all of the angles. I want one of them. Remember, since it is a regular polygon, all of the angles are the same. And how many angles did I have? 5. So that's why we take 540 divided by 5. And we would have 108 degrees for each angle. Okay, and then what if I have a decagon? How many sides and angles does a decagon have? 10. A deca means 10. Decade of a rosary, right? Okay, so we would take 10 minus 2 times 180, which would be 8 times 180, which gives me 1,440. Is that what I was looking for? No, because that's all of the angles together, right? I want one of the angles, so what else do I need to do? Divide by 10. There's 10 angles. If the total is 1,140 divided by 10, each angle is going to measure 144 degrees. Okay, questions on those ones? Okay, kind of taking that idea a step further. So we're going to find the missing angle measures. We're going to draw some nice little pictures here. All right, so let's draw. It's going to be, it has to be perfect, but kind of like that-ish, like a trapezoid, kind of, but not really. Okay, not drawn to scale. I want to make sure we know that. Let's start here. Let's say 112. This one's 98. That angle is X. And this one's 91. Okay, I want to find the missing angle measure, which there's just one of them. It's just that X right there. Now, we've done this quite a bit. We did this a lot with triangles, right? If you knew 3 angles of a triangle, you could find the third because the sum of the angle measures in a triangle is 180, but remember it changes depending on how many sides and angles it has. How many sides and angles does this figure have? 4. So if you're not sure what the sum of the angle measures of a quadrilateral is, we have that theorem, right? That formula that we just did, right? You could take 4 minus 2, which is 2. 2 times 180 is 360. We kind of maybe already knew that, right? A square and a rectangle add up to be 360. Any quadrilateral is going to add up to be 360, which means if I take 91 plus 112 plus 98 plus x, I'm going to get 360. So if I take 91 plus 112 plus 98, I should get 301 plus x equals 360, right? Looking for that missing 1. Let's put the 1 in there. Which means that missing angle measure would be 59. 59. Okay, let's try one that's a little trickier. Okay, number 6. Okay, easier shape to draw. It's going to be somebody last class said a boat. There we go. I don't know, boat maybe. Reminds me of an arrow. Kind of like arrow on both ends. Alright, so in this shape, the 2 points are going to be y. They're both going to be y. Okay, these 2 angles here are going to be the same. They're going to be 2y minus 20. Both of those are going to be 2y minus 20. And then those other 2 angles are also going to be 2y minus 20. Now, like I was saying, we've done this before, right? If you know some of the angles, we know that if it's a triangle, they add up to be 180. We learned in the last one that if it's a quadrilateral, they're going to add up to be 360. But this is not a triangle. It's not a quadrilateral. How many sides does this have? 6. This is a septa/heptagon, right? 6 sides. You know right off the top of your head the sum of the angle measures of a heptagon. I guess we kind of already found it in the second example, didn't we? Do what? We didn't find it. Anyway, oh, is that the first one on the left-hand side? 900. That's for 7. So we haven't found it. Sorry, guys. Okay, so we need to find the sum of the angle measures, right? Because I don't know. If I add all these together, I don't know what I'm going to get, and I need to find that out first. So I'm going to take 6 minus 2 times 180, which is 4 times 180, which should give me, now I see what you guys are saying, hexagon. I see what you got to do all that before. Okay, sorry. Is 720. So when I do add all of these together, I should get 720. And I don't know what the actual angle measures are, but I can add all of this together, right? I know that these 2 angles are y. So if I take y plus y, I get 2y. There's those 2 angles. And the other 4 angles are actually the same thing, right? You have 2y minus 20, 2y minus 20, 2y minus 20, 2y minus 20. So if you add all that together, you can have 2y, 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 which would be 10y. That would be 8y, which, yes, total is going to be 10y. Okay? And then you have your minus 20, minus 20, minus 20, minus 20, minus 80, equals, we said it was going to equal 720. So, yes, the 2y and 8y is going to give me 10y minus 80 equals 720. So 10y equals 800, which means y equals 80. But like always, really important to make sure you actually answer the question because they didn't really want to know what y is. They wanted to know what the angle measures are, which, that is these two angle measures, right? Those are going to be 80, but the other four are not 80. They are 2y minus 20. So we would need to take 2 times 80 minus 20, which would be 160 minus 20. So the other ones are 140. So the angle measures are 140, 140, 140, 140, and then 80 and 80. Okay, questions on those ones? Okay, now let's move into the other theorem that we talked about. So the other theorem, instead of talking about the interior angles, was talking about the exterior angles. The interior angles, the sum of the interior angles depends on how many sides and angles you have. The exterior angles doesn't depend on how many sides and angles you have. The sum of the exterior angles is always going to be 360. Always. That's what that theorem 6.2 told me. So if I have a 14 gon, so I have this figure that has 14 sides. It does say it's a regular polygon, which means all the interior angles are congruent, which by extension means all the exterior angles are going to be congruent as well. So if I wanted to find the sum of one of the exterior angles of a 14-gon, what would I do? What does all the exterior angles add to be?
360.
360, and how many angles are there?
14.
14, and they're all congruent. So you would take 360 divided by 14. I think the ones in your homework come out nice and even. This one does not. If we round to be about 25.7 degrees. And we do the same thing if I have a 42-gon, which would be a huge shape. How would you find the measure of one exterior angle? 360 divided by 42. Once again, this one doesn't come out perfectly evenly. I think the ones in your homework do a better job at that one. Okay, last thing. The sum of the interior angle measures is with sides is given, find in. So basically, I've got a shape. I don't know how many sides and angles it has. I don't know. But I know that if you add up all the angle measures, you're going to get this. So I'm going to kind of, like the first examples, I'm going to give you the answers. We've got to figure out how many sides would that figure have. So let's say I have this figure. I add up all of the interior angles, and I get 1,080. I want to know how many angles and how many sides are there. Well, I know the sum of all the interior angles. This is that theorem 6.1. What I did is I took n minus 2 times 180. I did that formula. I don't know what n is. I don't know what I plugged in for n. But when I did that, I got 1,080. So what you're going to do is you're going to kind of set up an equation, right, and solve for n, which is the number of sides. Now, to solve this equation, probably some of your gut reaction would be to distribute, which I totally get. But it's probably going to be easier, instead of distributing the 180, get rid of the 180. How could you get rid of 180? Yeah. Divide by 180. You have n minus 2 equals 6. So if you add 2, it means that figure would have 8 sides, an octagon. You'll have a few of those in your homework. That's it. You guys have questions?